here, we are skipping all the way to 4.6, which talks about mapping diagrams, the vertical line test, and domain and range. This is a loaded lesson, lots of important information here, so make sure you guys are taking good notes and are paying attention along the way. So first of all, let's go ahead and define a function. Okay, a function is a relationship that each input slash domain value with exactly one, we'll add one in there, output or range value. So as you guys can tell, domain and input interchangeable. Range and output interchangeable. So domain talks about our x values and range talks about our y values. We'll hit that later. Okay, first thing we're looking at is mapping diagrams. So a mapping diagram is a diagram used to show a relationship between the domain, which this over here is supposed to say x, and the range, which is our y values, as I talked about before. Okay, so the first two examples here are mapping diagrams. And we're trying to analyze, is this a function? So remember, in order for a relationship to be a function, each input, so each domain, has to have exactly one output. Okay, so what we're looking at, -5 will give you 4. If you input -2, it'll give you -1, 1 and 2, 3 and 4. So here's the deal. Every domain can share the same range, but a domain can't have multiple ranges. So our first example here is a function. In our second example here, if you input 1, you can get both -2 and +1. If you input 4, you can get both -2 and 2. So this one is not a function because both of these input values have multiple output values. So two things to note quick. X's cannot repeat. You can't have multiple outputs for each input, but your y values can repeat. Okay, so take note of that. All right, example number 2 here. Copy this table down for class, but we will talk about it together in class as a review. Okay, so creating a mapping diagram. This is another thing we'll go over together in class. Write down these sets of ordered pairs, and then we will discuss it once we get together. Very similar question to the ones that we already did. Okay, the next thing here is the vertical line test. So the vertical line test is a very important indicator of whether we have a function or not. So if any vertical line passes through more than one point of a graph at the same time, then it is not a function. So how to know if a vertical line passes through at the same time? A vertical line is at a particular x value, so that kind of crosses itself off. So how the vertical line test goes, first of all, copy down each of these 4 functions. Just sketch it, doesn't have to be perfect. So how we test the vertical line test is I'm just going to grab a line. Okay, not perfect on my end, you guys can probably do better. And just drop a line through each of the points on the graph. Okay, then check each of your vertical lines. Okay, my first vertical line only passed through one point, which is good. My second vertical line passes through multiple points. This indicates that this is not a function. Okay, let's skip the second example, but please copy it down for class. We'll do the third example and then copy down the fourth one for class as well. So when we have a solid line, so we don't have points here, it's not possible to draw vertical lines through every single point. So this is where you just have to, kind of estimate and use the eye test a little bit. So no matter where I drop a vertical line throughout this function, it is always going to cross at only one point within this parabola. So since it will only cross through one point at a particular time, this one is function. Okay, once again, copy down number 4 for class. Example number 1 here. Please copy down these points. We will do this one together in class. All right. Let's talk about domain and range together. We'll probably revisit this in class again. So sorry if you hear it multiple times. So for domain and range, remember domain is your possible x values and range is your possible y values. So in this first example here, we are finding the range. So this question says the domain of g of x, remember g of x is the same thing as just saying y, it is your outputs. So the domain of g of x, which is 4x minus 12, is 1, 3, 5, and 7. So they're saying those are your possible inputs to the function. Find the range. So these inputs that they give you, domain, represents your x values. So in order to find your possible y values, you're going to have to create a table. So just like we did in 4.1. So list all of your possible inputs. We've got 1, 3, 5, and 7. And our y values, I should have actually wrote this as our g of x values. So substitute in each of your x values into your function to calculate your g of x values. So I've got 4. So in my first one here, this would be g of positive 1. This is when we're inputting 1 into our function. This would be 4 times 1 minus 12. Put that in there. Okay, 4 times 1 is 4, minus 12 gives me negative 8. So negative 8 would be my g of x value. We'll repeat this process. So we've got g of 3 equals 4 times 3 minus 12. 4 times 3 is 12. 12 minus 12 gives me 0. So 0 is my output value, sorry. Next we have g of 5. That would be 4 times 5 minus 12. 4 times 5 is 20. Minus 12 gives me positive 8. And then finally, g of 7 would be 4 times 7 minus 12. 4 times 7 equals 28. Minus 12 gives me a positive 16. So that would be my output value. So remember, we talked about this, it was probably a chapter or two ago, but this right here is called set notation. That is when you are listing your possibilities. So for our range here, let's list all of our possibilities in set notation. So our range of this function would be all of our g of x values. So our range would be the set of -8, 0, 8, 16. Okay, those are our possible output values for each of these input values, each of the domain values. Okay, so that is everything for now in 4.6. We have a little bit to do together in class, but it shouldn't take us all that long. Thank you guys for watching.